Okay, looking at our second example in this harder distribution extension here. So again, following those order of operations, inside of my parentheses, I have no like terms, so nothing to do there, which jumps me to the outside where I can do some multiplication. I don't have any exponents I can do because, again, this 8 is not being raised to the third power like the y. That 8 has its own exponent of 1, and 8 to the first power is just 8. Same thing here with that 20 and that 5 and that 10 and that 15. So that's why we're skipping right from groupings to exponents to the multiplication, aka the distribution. So out to distribute here, I have this negative 10y. It's really important to keep that minus or that negative sign with that 10y. I'm going to start by distributing that to all of those pieces. So I'm just going to carry down 15xy while it's here so I don't forget. So negative 10, there's only a coefficient of 1 there, so that's going to stay negative 10. Y to the first times y to the fourth is y to the fifth. Negative 10 times a positive 5 is going to turn into negative 50. And y to the first times y squared turns into y cubed. And a negative times a negative is a positive. 10 times 20 is going to be 200. And x times y is just xy, or yx, either way, doesn't matter. Carry down that 8y cubed. That one's not getting distributed or multiplied by the negative 10y because it is not inside that grouping. Remember, we do not want to share our pizza with those peeps. So now just a quick look to see if I've got any like terms, and I definitely do here. I'm going to start with that negative 50y cubed and that positive 8y cubed. Although I'm going to carry down my highest exponent piece first to keep it in order. Combining those two is going to leave me with a negative 42, all right, because 42 plus 8 gets me back to 50. And that's staying y cubed, because remember, apples and apples, when you add those together, they stay as apples. And I actually have one more set of like terms. This 15xy and this 200xy can be combined to give me a positive 215xy. And there we are, all set, because we have no more like terms. Ooh, this guy's a doozy here in example 3. Yikes. So, starting off with my groupings inside, nothing in there to deal with. All those are their own individual pieces, nothing I can simplify. Which means I need to start by distributing this big ugly chunk to my top two pieces. Remember, that giant fraction bar, the giant fraction bar is like a grouping. Meaning that you need to simplify that entire top before you can start with the division on the bottom there. Okay, so we can do this. Let's math it. So again, just starting with those coefficients, a little bit more complicated here because we do have a fraction. So 2/3 times 6 over 1, 2 times 6 is going to turn into 12, and 3 times 1 is going to stay as that. I'll simplify that in the next step. And so now my exponents, my variables here. So again, I'm just going to do common bases only. I'm going to focus on common bases. So that y is a common base with the y to the fifth. So y to the first times y to the fifth is going to turn into y to the sixth. Then my next common base are my x's. X squared times x to the third is going to turn into x to the fifth. And there we have our first piece. Okay, keeping that minus sign, because a positive times a negative is going to stay that negative. 2 times 3 on the top is going to turn into 6. 3 times 1 on the bottom, remember those are both over 1, is going to equal 3. And y to the first times y squared is just going to be y to the third. And x squared times no other x's over there is just going to stay as that x squared. All right, so we have our top piece. Now I'm just going to carry down everything else that I haven't touched yet. Very important that when you're doing this, you don't get sloppy and that you can tell your exponents apart from your coefficients. So I'm just going to take another step and simplify those fractions because it'll just make my life a little bit easier. So 12 divided by 3 is really just 4 y squared x to the fifth minus 6 divided by 3 is 2 y cubed x squared. And that's all divided by negative 2 x squared y cubed. So remember here that this whole top piece is being divided by that, not just the first piece, not just the second piece, the entire piece. So when I'm doing that, it's basically like what we talked about in, let me see if I can find it, this distribution example. See here how we had both of these pieces being divided by that. We had to break it up into two separate fractions and each do that division. That's exactly what we're going to have to do here. So I'm just going to forward this way. And I'm going to turn that into 4 y to the 6, x to the fifth, divided by negative 2 x squared y cubed. Then I'm going to have that negative 2y cubed x squared, and that's going to still be divided by another negative 2x squared y to the cubed. And once you get to this part, this is where you can look at, if when in doubt, what I was trying to say earlier, but it didn't apply up there. When in doubt, just expand that out. Even if it's just in your head that you're expanding it out. Okay, so again, piece by piece, one piece at a time. Positive 4 divided by a negative 2 is just going to turn into negative 2. Y to the 6th on top and y to the 3rd on the bottom. That would be 6 y's up here. 1, 2, 3, 4, 5, 6. 3 y's down here. 3 of them are going to cancel out and leave me with 3 y's on the top. So negative 2, that's y cubed. If you're using your rules, 6 minus 3 is 3. If I have x to the 5th, that's 5 x's on top, 2 on the bottom. 2 of them cancel out, and that leaves me with x cubed. 5 minus 2 is 3. Looking at my blue piece, the negative divided by the negative 2 divided by the negative 2 is just going to turn into a positive 1, which I don't really have to write the positive 1 if I don't want to. Y cubed divided by y cubed is going to cancel out directly because, again, 7 divided by 7 is 1. X divided by x is 1. 3 y's on top divided by 3 y's on the bottom. Those are all going to cancel out, as are the x squareds. So I've got plus 1. I cannot just get rid of that entire plus 1 because if I did, that would mean plus 0. And plus 0 is not the same as plus 1. So because everything cancels out, we have to keep at least one there. And that is our final answer. So just take it slow in your practice problems and careful with those exponents.